if you stretch a rubber band out from one point to another, then if you know the coordinates of those points, you can figure out how long the rubber band is. Knowing how long the rubber band is, you can go to your graph of tension versus length, whichever graph seems to be most appropriate. And from that graph, you can find the length and you can determine, at least as best you can from the data you have, what the tension in that rubber band is, what force it's exerting on, let's say, the first point. So if you do that for two rubber bands, you could get a force F1 and a force F2. If you have the force F1 and the force F2, well, everybody in here's had statics and resolved plenty of vectors. I don't have to tell you much about that. You have F1 y component, F1 x component that add up to F1, F2 y component, F2 x component that add up to F2. If you add the two x components, F1x plus F2x, you get a vector, this one here plus this one here gives you this orange vector here. And the y components up this far, then back down this far, might lead you to a component in the y direction that's about like this. That would be your F1y plus your F2y. And your resultant force would then be this. This would be your F1 plus F2. Again, I don't have to be too specific here because I'm addressing people who know enough statics to completely understand what I'm talking about. And then, of course, the negative of this vector, the vector in the opposite direction, would be your equilibrant, which would be negative F1 plus F2. And it should be negative quantity F1 plus F2. To actually get the force vectors F1 and F2 for two rubber bands, they would have a common point. You'd have a different point out here and a different point out here, end of the first rubber band, end of the second rubber band. You could take those displacement vectors, just the vector from this point to this point and the vector from the common point to the second point, and divide each by its magnitude, giving you a unit vector, which you would then multiply by the force that you determine from its length. Very straightforward idea. Make sure you have that idea. That one seems to be difficult for people for some reason, and it's a little hard to imagine that for people who've had statics, but it could be something related to unfamiliarity with vectors and unit vectors and so forth. So just a plug for unit vectors, they're quite important.